everybody, I am Krishna Rao Patro. Today I will discuss about one important concept, that is wrapper class. How wrapper classes are used and what is wrapper class and how you can use and what are the different methods are there and how it is useful. Those things we will discuss. Wrapper classes wraps the primitive data types. That means in Java everything you have to represent in object form. So if you want to represent anything in object form, there must be corresponding classes. So if you want to represent your primitive data in object form, then that need a class. That class is your wrapper class. So wrapper class wrap the primitive data types. So underline the word wrapper class wrap the primitive data types, and that is why it is known as wrapper classes. We can also create the class which wraps the primitive data type. So whenever you want to represent a primitive data in class form, then that class is known as wrapper class. So Mr. James Gosling, he has designed various wrapper classes for every primitive data types. So whatever the data types are there in Java, for every data type you will find corresponding wrapper class. So in Java, wrapper classes are used to wrap the primitive data type into object. Okay. So whenever you want to represent the primitive data in object form, that time you depend on wrapper class. It is useful while working with the collection. That means whenever you are using collection concept, in the collection everything will be stored in terms of object. So if you want to store a primitive data in collection, then the primitive data also you have to convert into object. That object you can store in a collection, where only object can be stored, not primitive data types. So collection will allow only to store objects. So if you want to store primitive data, then you have to convert the data into object. So that time you need wrapper class. The wrapper classes also provide additional methods and can be useful in processing the wrapped data. So in the wrapper class you will find corresponding methods also, some set of methods where you can do some processing. So those things also we'll discuss today. So these are the main concepts related to wrapper class. Now you can see here what are the primitive data types and what are the corresponding wrapper classes. And you know that Java supports 8 different varieties of primitive data type: double, float, long, integer. These are the 4 different data types, and 5, 6. So these are all the numbers. Some are pure number, some are decimal number. Actually the first 2 are decimal and these last 4 are pure number: byte, short, int, long. They are primitive data types. Similarly char, similarly boolean. Totally 8 different primitive data types. If you observe here, every primitive data type written in lowercase. So because these are all one type of keywords related to data type. Now if you see the corresponding wrapper class, for double the wrapper class is double, whereas here D is uppercase, here D is lowercase. So whenever you are writing in lowercase, that represents primitive data. If you write same thing in uppercase, that represents your double, means the wrapper class. Similarly float, here F is lowercase, here F is uppercase. So float is a data type, whereas here float is my wrapper class. Similarly long is my data type, this long is my wrapper class. So here observe here every letter of the wrapper class is uppercase. Similarly int, for int you have to write pure form, integer. So here I is also uppercase. So my integer is a wrapper class for integer data type. Similarly short is what? My data type. Here S uppercase, this short is my wrapper class. Similarly byte, B lowercase, here B uppercase, this byte is my wrapper class. Similarly char is my data type, character is my wrapper class. Here C is uppercase. Similarly boolean, B is lowercase, here B is uppercase. So how many wrapper classes are there? You will find 8 different wrapper classes. For every primitive data type you will find corresponding wrapper classes. All the wrapper classes are available in java.lang package. Java.lang package. So in the language package you will find the corresponding classes. Inside the class you will find the respective method for processing that data. Processing data means what? You can convert the data into integer, or that means to primitive data, or you can convert the string into integer like this. Various methods are there. Or you can convert data into one form to another form. So you will see how you can use and what are the methods are there. So to know the methods of a particular class, I think I told in the previous session, there is a tool called Java P. Using Java P, you can find out what methods are there in the corresponding wrapper classes. So use this Java P tool. Using this Java P tool, you will be knowing what are the various methods available in each wrapper class. So totally how many wrapper classes? There are 8 wrapper classes. And those wrapper classes belong to which package? This is belong to lang package, because these are all related to language. So every language supports the primitive data type. For every primitive data type, you will find corresponding class. That class is called wrapper class. Now, there is a concept called autoboxing and unboxing concept. So whenever you are keeping the primitive data inside a class, then that means you are wrapping. So whenever you are wrapping, that is called boxing. That is also known as autoboxing. What do you call? Autoboxing. Autoboxing refers to the conversion of a primitive data into an object of the corresponding wrapper class called autoboxing. Whenever you are storing primitive data into an object, that is called autoboxing. For example, converting int to integer object. There you need the concept of autoboxing. The Java compiler applies the autoboxing when a primitive value is passed as a parameter to method or assigned variable to corresponding wrapper class. So automatically the compiler will apply the autoboxing concept whenever you are passing a parameter to a method, then automatically it will convert into object. Similarly, whenever you are assigning, there also it will convert the data into autoboxing. So pass as a parameter to a method, expect an object of corresponding wrapper class. Similarly, assign a variable to the corresponding wrapper class. Now see this statement, integer a equal to 5. This is one autoboxing statement because the 5 is stored in the object a. That means internally it will create an object a. There the 5 is stored. So 5 is wrapped in a box. That's why we call autoboxing. Similarly here, character ch equal a. If you write character ch equal, now ch is what? It's an object. Inside the ch object, the value a is there. So that means all the primitive data wrapped in a box. So this is a wrapping statement for character data. Similarly, float f. This is also one wrapping statement for floating point data. That means internally it creates an object f. In the f object, the value 2.3 f is there. So whenever you are writing this statement, this is called autoboxing statement. These are all autoboxing. So for every corresponding primitive data type. Similarly, boolean b equal true. Now b is what? It's object. Similarly, byte b. This is also an object where the value 42 is stored. Similarly, byte, wrapper byte. This is also an object where is storing b. B is what? The boolean value that is stored here. Similarly, short s, 23. So 23 is now stored in the. So these are all wrapper classes and these are all wrapper class objects. So whenever you are assigning some value to the wrapper class data, automatically the autoboxing concept will be enabled. So the process of storing the primitive data in an object is called autoboxing. Similarly, there is another concept called unboxing. Unboxing means what? The quite opposite of autoboxing. Boxing means you are storing, unboxing means to retrieve it from the box. So unboxing on the other hand refers to the converting an object of a wrapper type to its corresponding primitive value. So whenever you are coming from object to primitive form, then that is called unboxing. From object to corresponding primitive. This process is known as unboxing. Okay. Whereas if you are storing primitive data into an object, that is called boxing. If you are storing, this is unboxing. Whereas if you store primitive data into an object, then that is known as boxing. That is called boxing. Okay. Now see a small example. Integer v equal to 23. This comes under boxing because you are storing the value 23 into an object. Whereas if you come here, this second statement, you are storing v in a. Now a is what? My primitive data. So into the primitive data, you are assigning one object. Automatically from the object, the value will be coming. So this is called unboxing concept. So your program may need boxing as well as unboxing also. Now let us see a small example. A class unboxing example. Integer. See, when you write integer, this is what? Wrapper class. Wrap int equal to 42. Now that means you have stored 42 in an object. So this comes under boxing. This is your boxing concept. Again, int unwrapped int equal to wrapped int. So wrapped int is my object. From the object you are getting this value. So this means you are converting the object into primitive one. So that is your concept unboxing. Converting integer to int. Similarly, double wrap D. So 3.14. Now 3.14 is available in an object. So this comes under boxing. Sometimes it's a boxing, sometimes auto boxing. That means automatic boxing. Converting double to double. Primitive data to object form. Similarly, double wrapped unwrapped. So that means it is unboxing. It is unboxing. So auto boxing converts double to this. Unboxing converts double to double. So in your program, you may use corresponding type of methods. A small example of boxing, you can see int a equal to 50. This is what? A simple statement. So it is not boxing or unboxing because you are using a simple variable and simple constant. This is a normal statement. It is not under boxing or not unboxing. Whereas if you write this statement, integer a2 equal to new integer of a, that means you are putting that a into the object. Automatically the object a2 will be created. In the a2 object the value 50 will be stored. So that means you have given a cover, you have given a small box to the object, means to the value. So this concept comes under a boxing. Again, integer a3 equal to 5. This is also one type of boxing only. So the boxing can be written either this way, first way, or it can be written a second way also. Both are correct. Now when you are printing, you can print directly. A2 is the first object plus A3 second object. So in A2 I will get how much value? In A2 I will get 50. In A3 how much is there? 5. So 50 come from A2 and 5 come from A3. So that means A3 is also another object where value 5 is there. So in your program, especially in the object and program, every information can be stored in object form. If the data is in object form, always it is more secure. It provides more security for the data. That's why Java is more useful in the application. Another unboxing example. Integer I equal new integer 5. This is which example? This is boxing. Because we are storing 15 object. What is the name of the object? My I is the name of the object. Inside the object, my value is how much? 50. So 50 is available. Now, from the box, I have to get it. So how to come back from the object? So you have to write a statement like this. If you write int a equal to I, automatically a is a normal variable. There, you are getting the value of I. I is the object actually. From the object, I am retrieving how much? 50. So 50 will come here automatically. So it is a normal variable, whereas this is object variable. This is object. Whereas this is primitive data. This is primitive data. So now you can print. So while printing, you can print directly. So automatically, while printing, it will do unboxing. Okay. Similarly, you can write system.out.println I also you can write. So automatically the value 50 will be displayed. That means while printing, what it will do? It will retrieve the data. That means it will apply unboxing concept. So another example, autoboxing and unboxing with the comparison operator. If you want to compare two data, there you can use the comparison operator. Autoboxing can be performed with comparison operators. Autoboxing can be performed with the comparison. For comparison, you need what? Relational operator. So what are the relational operators are there? You can use less than, greater than, less than equal to, greater than equal to, double equal to, not equal to. Any kind of relational operator you can apply on the object. So while comparing, what it will do? It will compare with the real data. So how it will do comparison? First it will do autoboxing. Then it will store it. While comparing, it will do unboxing. First data will be stored in a box. While comparing, it will do unboxing, then compare. Let us see the example. Integer I equal to new integer 50. Now here, what is that I? I is my object. In the object, how much value is there? 50 is there. So in this example, now here I am comparing I is less than 100. But I is what? I is the object. Inside the object 50 is there. Now you are comparing 50 with 100. So internally it is doing unboxing. So when you are doing unboxing, you will get directly 50. So that means you are comparing 50 with 100. 50 is less than 100. Answer is yes. Then come here. Then prints I. Then what is the value of I? The value of I is 50. So answer is 50. Okay. Of course, if you want to write, you can write else statement also. Else, if it is not less, then you can write system.out.println. Then you can write not less. Some message you can print. This you also can write. So that means while comparing the data, here it will be applying autoboxing and unboxing concept. So in object-oriented programming of your Java concept, there always it uses autoboxing and unboxing. Most of the time in exam they will ask what is autoboxing, what is unboxing. So please remember, autoboxing means keeping the primitive data in object form, whereas unboxing means retrieving the data from object to primitive data. That is unboxing. That means they are quite opposite. Another example where, because I told you, when you are using collection, whenever you are using collection generally stores data in object form. Collection means it is a small area where you can store some set of data. In a collection, I can store any kind of data, but data must be in object form. So if you want to store data in object form, then how will you store your primitive data? So whenever you want to store your primitive data in a collection, then the data must be first converted into object. So if you want to convert into object, then internally it will convert into boxing form. It will create a box and store it. So one of the collection is array list. Array list is one of the collection. This is a special class. This particular class available in a package called util package. Using array list, you can store any number of integers. You can store any number of characters. You can store any number of string. You can store any number of float. There is no limit. And means indefinite. There is no limit. Infinite number of data can be stored. So now my goal is store set of integers. Set of integers in a collection. Which collection I want to use? I want to use the collection called array list. So now initially I will create one empty array list. Array list, see the syntax. Array list within angle bracket integer. That means I am going to store integer object. I have written integer. Integer is what? It is a wrapper class. Followed by AL. AL is what? My object. Array list is the name of the class. AL is my object, and initially I am initializing. That means object is initialized. Initially empty. Now AL dot add 1. So when you write add 1, what happened? Immediately the 1 will be stored in an object. That means it will create a box and store. Similarly 2, add 2. So it will not store 2 directly because it will be create first box then store. That means the 2 will be stored in a box. That box is nothing but object. Similarly add 24. Automatically 24 will be stored in an object form. So whenever you are storing in object form, it internally it uses the concept of boxing concept. That means what? It is creating a box and storing. Fine. So first object, second object, third object. Now whenever you are printing the complete array list, what will happen? You will be getting 1, 2, 24. All the item will be displayed. So this is the way your collection uses the concept of boxing. So always collection uses auto boxing concept to store your primitive data. So this is a simple example. Now I will show you some more methods of your wrapper classes. Now you have seen only the boxing and unboxing concept. There are other concepts also available. Now let us see through a small program. I told you there are 8 different types of primitive data types. Now first we will start with integer, because one of the common usage of wrapper class is integer class. INTEGR. Integer is the wrapper class for int data type. And this integer class belongs to lang package. Now let us show a small demo. Class wrapper demo, wrap demo. This is my class, because whenever you want to write a program in Java, always starts with class. Let me write my static method. Public static void main string arguments array. This is what my static. Now integer I equal to HTML 25. Integer j equal to assume 30. Now here we are storing how much? 25 in I, 30 in j. Now this is my wrapper object. I is my wrapper object, j also my wrapper object. So here it uses which concept? It uses boxing concept. Similarly, j also what? It is also wrapping object. So that means this also uses boxing concept. Now if I write here int assume k, int k, that means it is a normal primitive variable, whereas here I is object, j is object, whereas k is normal variable. Now if I write k equal to I plus j, now I want to print the value of k. System dot out dot println, what is the value of I? That value I want to print first, plus I printed. Now I want to print j also, and I want to print c also. So now print j and print k. Control S, wrap demo dot Java. Okay, my program saved with the name wrap demo. Go to the command prompt. I want to compile it now. Yes, Java C wrap demo. Now program is compiled successfully. After compiling, now let us run Java wrap demo. Yeah, now I got how much? 25, 30 and 55. So here while storing in k equal what? I plus j. So here I is my object, j is my object. So when you are adding two objects and we are doing addition operation, so internally what it will do? It will first unbox it. After unboxing, you will get the corresponding value. My values are 25 and 30, and after that it is doing operation. So here it is doing unboxing. After unboxing, I will get the value and do add and put in K. So now the value is 30. Sorry, 30 plus 25, 55. And finally print I value, J value and K value. So while printing I, it is doing unboxing and printing. Doing unboxing and printing. Similarly, while printing J also, it is doing unboxing and printing. It is doing unboxing. Similarly, while printing K, it is doing nothing because K is my normal primitive data. So for primitive data, boxing and unboxing concept not required because that itself is a primitive one. So boxing and unboxing requires when you are translating from object to primitive or primitive to object. In that case, boxing and unboxing required. For primitive, simply if you are printing primitive data, no boxing, no unboxing. Now let us see what methods are there in wrapper classes. So how to know? I told you there is a tool called Java P, Java dot lang dot Java dot lang dot integer. So you should know in which location that wrapper class are there. Once you know, then you will know the list of methods. Press enter button. Yeah, there are many methods are there. Now see, so many methods are there. So what I will do, I will transfer this data to a temporary file called x.txt. What I am doing, I am transferring the list of methods into the class, sorry, into a file called x.txt. Instead of displaying on the screen, I have transferred these methods into one file called x.txt. Now that x.txt I will open to my editor. Yeah, so I got, these are my methods are there. So now there is method called, please observe here, one of the frequently used method, int value. Int value is what? It is a method of which class? Integer class. So if you want to get the integer value of integer object, then you can call int value. So that means what? Please observe here. Here I is my object, j is my object. Now I want to apply that method. Assume int a comma b. So I can retrieve the value a equal to I dot, because I is object, int value. Int value is what? It is my method. This value and this method I am calling. Once you call this method, then that will return the corresponding integer. So there I am storing. So actually this is the real way of calling. But because of autoboxing and unboxing, this int value we are not using. So that means internally this boxing uses int value method. So that means internally uses, sorry, unboxing internally uses int value method. This method is used internally to retrieve the data. Similarly, b equal to, I want to get the value from j. So how to write? You tell me. So I can write j is object dot int value. If I write, I will be getting the data from the box. So that means this is also one type of unboxing technique. So internally unboxing uses int value method. So now I got what? A value and b value. Now let me use one c. Now if I say c equal to, I want to apply a minus b. A minus b. I want to do subtraction. What is the value of a? A is 25. What is the value of j? Sorry, what is the value of b? That is 30. So now I am doing how much? A minus b. A is how much? 25. B is 30. So 25 minus 30. If I do, how much I will get? I will get minus 5. So now I want to print the value of c. After subtraction, I want to print value of c. Yeah, Control S. Now let us run. So now I have used this method. Actually there are many methods are there. So I am using this particular method. Let us run. Compile the program. Yes. Yeah, I got c equal to minus 5. Did you observe? So this is the way you can apply the methods of wrapper class. So in this program I have used the int value method. So whenever you want to retrieve the integer value of the integer object, then you should call int value method. So unboxing internally uses this method. Similarly, if you want to get corresponding long value, then you can call long value. Similarly, float value, that means internally if you want to convert into long, then you can call long value method. Similarly, one of the very method means important method called parsing. Assume I want to apply parsing method. Parsing is what? It will be translating from string data to integer data. I will have one more plus control N. I want to use the parsing method. ParseInt. ParseInt is a method which takes one string object and that will return one integer value. And this also belongs to integer class. And remember, whenever you are using any method of the wrapper classes, actually wrapper classes belong to lang package, and this lang package is a default package. You need not import. So even if you write also, there is nothing wrong. You can write also import java.lang.star, but this statement is not required. Generally you should suppose write, but not required. Now class, assume I am writing int demo. This is my name of the class. Public static void main string arguments array. Here, what is my goal? My goal is to apply the parsing method. This is the method. What it will do? It will convert the numerical string into integer. Convert numerical string into integer and primitive data. So now I think you know what is the numerical string. There are different types of strings are there. For example, I will say within double quote. When I say string means always it is represented within double quotes. As you will write here A, B, C. Now in this string you will find only alphabet. So this is called alphabetic string, because you will find only alphabetic. Whereas if I write here, if I write 1, 2, 3, so all are digit. So this is called numeric string. So this is alphabetic string. Alphabetic string. Whereas this 1, 2, 3 is called numerical string. So that means a string can have only alphabet or it can have only digits also. Whenever we are having only digit, this is called numerical string. Numerical string. Now, one more thing also there. For example, I am having ABC 1, 2, 3. So you are having alphabet as well as the numeric. This is called alphanumeric string. This is called alphanumeric. Alphanumeric. So whenever we are converting this numeric string into its corresponding primitive, that time you need parsing. So parsing is a method useful to convert numerical string into integer. Convert numerical string into integer. So now assume I am having a string A equal to within double quote 1, 2, 3. Another string having B equal to 2, 3, 4. It is a string. String means you should write within double quote. Then only that is called string. So remember in Java, if you are representing a string, you should write within double quote. Now I want to add this 1, 2, 3 and 2, 3, 4. Actually 1, 2, 3 is what? It is a string format. And this 2, 3 is also string format. So now I want to add these two values. So first of all I have to convert the string into numeric data, then I can do addition. So now I am declaring the variable int ijk. Now my goal is convert the data into integer, then do addition. Now what is my goal? Add two numerical string. Add two numerical string and get its corresponding integer value. So whenever the question is given like this, what to do? Add two numerical string. So now here you can apply that method. Which method? The pass-in method. So the pass-in method, what it will do? It will convert the given string into integer. So now I am applying the pass-in method. So remember, pass-in is a method which takes a string and gives you the corresponding primitive data. If at all the string is not a numerical string, then it will throw an exception. It is not a number format, because pass-in converts only numerical string, not alphanumeric or not alphabetic. Those type of string you cannot pass. That one you should remember. Most of the time the students are making mistakes here. They will pass alphabetic string or they will pass alphanumeric string. That time that will throw the exception. What is the exception? Number format exception. So to avoid that one, always pass numerical string. Numerical string means what? The string consists of only digits. So that type of string it can convert or it can pass it. So now I am using this one, numerical string. So I will go to my program. So now it is a numerical string. It is a numerical string. Now this numerical string I can convert into integer. So how to convert? For that I will write here I equal to, there is a class called what? Integer class. This is my wrapper class. In this wrapper class, my method parseInt. This method, it can convert the numerical string, that is my a. Now convert that a into integer. Then here I am storing I. So I is my corresponding primitive data. A is my numerical string. So whenever you are converting numerical to primitive, use this one. Next, j equal to integer dot parseInt of b. So now I got what? The primitive form of a and b. After that I will get k. Now k equal to, assume I want to add, so I plus j I can get. I plus j. Yes. Now I will print it. System dot out dot println the k value I want to print. Now k value how much? Now k is plus k. So I am printing now. What is the name of the program? Int demo. Control C, Control S. Int demo dot Java. Save it. Now my program is ready. Go to the command prompt. Java C. Int demo. Yeah. Now it is compiled. After compilation, I got my bytecode. Now how to run? Java int demo. Now when I am running, yeah, I got 357. Why 357? Because 123 plus 234. So I'll get 357. So whenever you are adding two numerical string into a numerical form, first of all you have to use parseInt to get the corresponding integer, then do the addition. But if I write here, for example, I am having another string c. If I write c equal to a plus b, in that case what will happen? C equal to a plus b. Now what is the value of c? If you write, for example, here I will write c value. Now c is what? Numeric string plus numeric string. That means here I am not converting to integer. Directly I am adding. So 1, 2, 3 plus 2, 3, 4. So that means it's doing string concatenation. So my answer will be concatenate string. Compile it. Yeah, here I got my C value 1, 2, 3, 2, 3, 4. So that means it is combining two string. So that means when we are using plus operator for string, it is concatenate, joining. Whereas if you are doing plus operator for integer, it is doing numerical addition. So for two string, if you want to add, always use parseInt. Okay. So this is which method? parseInt method. Similarly, there is one more method you should know, one important method called toString. So remember, there is a method called toString. So the toString method, what it will do? It will convert the string into, it will convert the integer into toString. That means I will give a numerical data. The numerical data I want to convert into integer. The numerical data I want to convert into numerical string. For that, you can use toString method. So now let me use toString method to convert primitive data into string format. Let us go to this program. Assume I am having int p equal to 23, int q equal to 45. Got it? P is what? Numerical data. But I want to get its corresponding string format. So string s1 comma s2. S1 should get its corresponding numerical string. How to get? Integer is a class dot toString of p. So if I write this statement, what will happen? It will give me the data in a string format. Actually, what is the value of p? P is 23. So this 23, which is converting into double quote 23. So whenever you want to convert primitive to string, then use toString. Whenever you want to convert string to integer, then use parseInt. So parseInt for this is, here it is converting. For example, let me change this one. In fact, 123 I will say 12. 1, 2. Here I will say 2, 3. So now this string 12 will be converted into integer 12. Similarly here b is how much? B is actually 2, 3, which is given in string. This 2, 3 I am converting into integer 2, 3. String to integer is parseInt, but integer to string is toString. So whenever I am writing this one, automatically the data is converted into string format. Next, now I need the q also. So how to write? Tell me. The data has to store in S3, S2. S2 equal to integer dot to string within bracket q. So when I write this statement, what happens? Automatically the value 45, which is the numerical form, that can be converted into corresponding string 45. So remember, when it is a string, you read as a 45. Don't say 45. Whenever it is integer, you say 45. Whenever it is a string, you say 45. That is the correct way of pronouncing. Now I want to add toString now. That means I want to join toString. So there, what you will do? System dot system dot out dot println. I want to add s1 plus s2. So it will do what? String concatenation. String concatenation. Now let us run. Go to the command prompt. Yes, compiled successfully. Java int demo. Yeah, I got 2, 3, 4, 5. Did you observe? This is came from s1 plus s2. For your clarity, I may write s1 plus s2 equal to, simply I want to print a message. Compile. Yeah, I got s1 plus s2 is how much? 2, 3, 4, 5. So these are the various methods are there, and then when you need, you can use corresponding method. Now I want to use one more method called 2-hex string. That means I want to convert my numerical integer into hexadecimal string. Hexadecimal string. So I want to apply this method 2-hex string. Because sometime in exam they may ask a question, convert the given data into hexadecimal form. Then you can use 2-hex string. Let us use 2-hex string. Same program. Let me define int. Assume my value v equal to, assume my value is 123. This is my value, and this is given in which form? Decimal integer. This decimal integer I want to translate into hexadecimal form. So for that I can use 2-hex string method. But 2-hex string is what? It is a part of integer class. So how to call this method? To call this method, always you write like this: integer dot 2-hex string, and requires what? That integer value. This is my variable v. So when I pass this one, then I am getting the corresponding string hexadecimal hx. So now hx is what? My corresponding hexadecimal value of 123. So let me print both. What is my v value and what is my hexadecimal value? Hexa value. First I will print my value v. Value v is what? It is given in integer format. I want to print its corresponding hexadecimal. So here I am printing hexadecimal value. The hexa value I am storing in a variable called hexa, that is given in string format, and print that one. So now you are able to convert the primitive data into corresponding hexadecimal string also with the help of 2-hex string. So these are the methods you should know. So these are the methods available under wrapper class. So in every wrapper class you will find set of methods. So you can use the Java P, know the methods, apply it. So depending on the requirement you can use. Let us run. Compile it. Run it. Yeah. Now my hexadecimal string is 7b. V is 123. Its corresponding hexadecimal value is 7b. Is it clear? So this is the way you can convert the integer value into corresponding hexadecimal. For example, now I will write instead of 123 I will say 12 only. 1 2. If the value is 1 2, that means 12, then what is the hexadecimal value? Actually 12 is decimal integer. Decimal value. Its corresponding hexadecimal how much? Hexadecimal. Actually A is 10, B is 11, C is 12. So that means its corresponding hexadecimal is C. So now if I run the program, I should get C. So if I give V is 12, its corresponding hexadecimal value is C. So I should get C. Let us run. Compile it. Yeah, I got. Did you observe here? Here I am getting how much? C. So try to know what methods are there. Similarly, if you want to get corresponding octal, then you can use 2 octal string. Binary, 2 binary string. You can apply the 2 binary string also. Sometimes they may ask, give me its corresponding binary value. If you want to get binary value, you can apply like this. Of course, remaining thing you can try yourself because you know the now technique. This is hexa and 2 binary string. Now here I write integer dot 2 binary string, that gives you binary string. So I am storing in binary string. Bins binary string equal to this. So that means this method returns a corresponding string value. Now let me print its binary value. So binary value is available in bins, binary string. I am printing here. This is binary string. Binary string. Okay. This is your hexadecimal string. Hexa string. Now let us run. Clear the stream. Java C. Our program name is int demo. Compile it. Now it is saying semicolon expected. There is a small mistake. Yeah, hexadecimal is a string method. Method means you should write like this. Corresponding method. Control S. Now compile it. Still two binary string. Which one you want to convert? You have to pass the parameter. Yeah. Here I have to pass the parameter. So I'll pass V. So V is my parameter. Yeah. Because for V I want to convert into binary string. Compile it. Java int demo. Yeah, I got, because the binary value of 12 is 1100. So I got this one. So this is the way you can apply all the methods of wrapper classes. So try to know what are the methods are there. 2 string, 2 unsigned string, 2 hexa string, 2 octal string, 2 binary string, formatted unsigned string. There are a lot of methods are there. Whichever method you need, you can apply it. So try to know first of all what methods are there. Byte value, short value, int value, and what is the hash code, and what is the, similarly you can apply get integer also. And remember, all the methods are static method. That means you can call through class name. If it is a static method, you can call through class name. You need not create object and then object dot method, not required. Directly you can call through class name. That is the speciality of static methods. Fine. Similarly, reverse an integer. You can call one reverse integer. Let me give, I want to use reverse int. Reverse int is what? Reverse integer. It will take integer data. So let me pass my integer. Assume my V is how much? 12. So I am giving V. So I am calling my reverse integer dot reverse. Then that returns what? That returns a primitive data. That returns one primitive data. So now I am storing, I am declaring one variable called reverse int. Reverse. This reverse variable should give me the reverse value of V. Now let me print what is the reverse. Control C, Control V, reverse integer. Reverse. So now I am storing in REV and I am printing that one. Control S. Yes, I compiled it. Not Java. Int demo. Here I got what? 8053.058. It is giving its reverse equivalent. I have given the what value? The V is actually 12. So internally it is reversing its byte and converting that byte into corresponding integer. So that value I am getting. So you can apply any other method and do it. Similarly, there is a method called bit count. How many bits are there? For example, I want to apply bit count also. bit count for V. Bit count, bit count of the value V, and this is under which class? Integer class. So you can write integer dot bit count. So can I call directly? Yes, it is a static method. So if it is a static method, you can call directly. So I am calling directly and printing its corresponding bit count. So in V, how many bits are used internally? So let us compile it. Yes, compiled successfully. Why is it not printing? Did I save or not? Control S, save the program. Then I am printing its bit count. Not reverse, bit count. Now go to the command prompt and compile it. Java C int demo .java. After compiling, then run it. Bit count. In bit count, I think C is uppercase. So this method bit count, you have to use C uppercase. So it is a case sensitive. Put C in uppercase. Control S. So you must be very careful while writing the Java program. It is a case sensitive language. Yes. Now Java int demo. Yeah. Here only two bits are set bits. Set bits means this 1 and 1. So how many set bits are there? For example, I may use 15, 1, 5. If I use 15, then what should we get? If I get 16, I should get here F. Let us 15 means actually compile it. Then 4 ones, 1, 1, 1. So that means it is getting set bits. How many bits are ones are there? So this bit count, it counts only once. So these things you can apply this. Okay. So this is the way you can solve the problem. So there are many methods are there. So today we have discussed only the integer. Actually, depending upon your application requirement, you can use those corresponding methods. Similarly, rotate left, rotate right, and signum, reverse the bytes, and what is the maximum value between the two integers, you can find out also. So minimum value between the two integers, so you can find out this. So try to know what methods are there in the wrapper class. Like this, if you want to know, I want to know what are the methods are there in the character wrapper class. So Java P, Java dot, lang dot, character, array, ctr. Yeah, in the wrapper classes of character, there are many methods are there. Assume you want to check given character is a alphabet or not, or given character is a digit or not, or given character is a special character or not. If you want to know that one, you can use any of the method of this wrapper class, character wrapper class. Now let me store in a y.txt, then open that file. Yeah, now this is, you can get corresponding uppercase, lowercase, delimiters. There are many attributes also there. Character count. If I give a string, how many characters are there? You can count it. Similarly, you can convert into lowercase, you can convert into uppercase, and whether the given character is a lowercase or not, whether given integer which is in lowercase or not. So these are the corresponding methods. Whether it is a title case or not. Title case means the first letter is uppercase. Similarly, whether is letter or digit. Given character is a letter or digit. To know that one, you can apply this. Is letter or digit. Given integer value, corresponding ASCII value. If you give, it will give the true or false. Similarly, is a Java letter. Each alphabet, whether given ASCII value, is a representing any alphabet or not. So whenever you want to check any character, so you can use these methods. If you want to convert given character into two lowercase, so you can use two lowercase. Similarly, if you want to convert into uppercase, you can use two uppercase. Similarly, you want to check whether given character is a white space or not. So these are the various methods are there under this character wrapper class. So every wrapper class is having set of methods. So those methods you can use. So I hope you got the idea about how to use the wrapper class and what are the methods are there and how you can use in the program. So now in the future days we will be using all the methods. So practice all the program. Okay. So these are the programs. Remaining things you will see in the next session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.